Welcome back to chemistry class. Today's lesson is on the topic stoichiometry, which is really an important topic to calculate the numbers and the mass of the atoms and compounds participating in a chemical reactions. Let's start. What is stoichiometry? It is a Greek word. Stoichio means an element and metry means measurement. In stoichiometry, we learn how to count atoms and how we calculate their masses. How many and how much. Let's start from an equation. If you look at this equation, you notice there are two types of numbers. One number has been given on the left side before a compound, and the little numbers on the right side as a subscript. We already know the subscript represents the number of atoms in a compound. We will discuss step by step. Let's talk about the little numbers on the right side as a subscript. If you see, there is no number with n on the right side. When there is no number, it means it's 1. With hydrogen, you see there is a number 3. It means 3 atoms of oxygen. 2 with O, it means 2 atoms of oxygen. You see 2 with H, it means 2 atoms of hydrogen. No number with O, it means 1 atom of oxygen. No little number with N, no little number with O. It means N is also 1, O is also 1. Let me show you in the form of a table or a chart. Then you will know what do they all mean. 1 nitrogen atom and 3 hydrogen atoms, 2 oxygen atoms, and here 2 hydrogen atoms and 1 oxygen atom, 1 atom of nitrogen and 1 of oxygen as well. Now let's talk about the big number on the left side in front of a compound. These big numbers 4, 5, 6 and 4 which you see in this equation are called coefficient. This coefficient affects both nitrogen and hydrogen. We know nitrogen, no number, so it was 1 atom. Now this 4 would change. 4 multiplied by 1, it becomes 4 of nitrogen atoms and 12 of hydrogen atoms. Here 5 times 2, so 10 oxygen atoms. 6 times H2O, so hydrogen became 12, oxygen became 6. Nitrogen and oxygen both became what? 4. Remember the difference between subscript and coefficient. Let's move on. This 4, this 5, this 6, this 4, those are ratios we can see in this chemical reaction. 4:5, 6:4. It is more than just multiplication. 4, 5, 6, 4 means 4 molecules of NH3 react with 5 molecules of oxygen to form or to produce 6 molecules of H2O and 4 molecules of NO. One more time, 4 molecules of ammonia react with 5 molecules of oxygen gas to produce 6 molecules of water and 4 molecules of nitrogen monoxide. Another word we can use instead of molecules, moles. 4 moles of ammonia react with 5 moles of oxygen to produce or to form 6 moles of water and 4 moles of nitrogen monoxide. If you understand this ratio, then it would be easy to solve a given problem. Let's solve a problem now. How many moles of H2O are produced if 2 moles of O2 are used? There are 2 methods we can solve this problem. I will show you both so that you can understand and you can solve with one of them you are comfortable with. Okay? Step number 1, you must have an equation for the reaction which question is asking about. Second thing, after equation must be balanced. Start from given data. What is given data? 2 moles of oxygen. So write down here oxygen O2. Now what question is about? How many moles of H2O? So write down here H2O. Look at the equation. How many moles of oxygen? We see 5 in front, so 5. How many moles of H2O in the equation? 6. What is the question now? Question is 2 moles of oxygen. So under oxygen, I put 2 moles. How many moles of H2O? We do not know. So here I would put X. After setting up this ratio, we multiply these ratios with equal sign and cross multiplication. Cross multiplication like this. What does it mean? 5 times X. We got 5X is equal to 2 times 6 is 12. Now, both sides divide by 5 because it's 5x. Divide by the number which you see with x. And in order to balance, 12 also divide by 5. These 5 cancel. What we get now, x is equal to 12 over 5. Use your calculator. 5 times 2 is 10 and decimal 2.4 mole is our answer. That is the ratio method. But nowadays another method is very popular, recommended by US curriculum of chemistry and calculation. Okay, if you want, you may write it down, you may take a picture, a screenshot. If something not clear, any question you come up with, don't hesitate to ask us in comment section. I'm going to erase it. Let me show you the other method. What's the other method? Again, start from the given data, 2 moles of O2. Now, multiply by what? The ratio of the moles of H2O and O2 given in the problem, in the equation. What is the ratio? 6 and 5. And remember that the one which is given is always, you multiply it always at the bottom as the denominator. The other one as a numerator. Right? Again, where these 6 and 5 came from? From the equation. And we are multiplying. Okay? So, now this 5 and 6 from the equation. Now we are solving. Mole O2 on both sides. Cancel out. What we got? 2, 6 over 5. So 2 times 6 mole of H2O divided by 5. So what we get now? 2.40 mole of H2O. Same answer like we did in our previous method. 6 and 2 multiply together, divide by 5, you got 2.40 mole. Clear? Let's solve another problem. How many moles of NO are produced in the reaction if 15 moles of H2O? So where we would start? Moles of H2O. Here. Multiply by the ratio. Which two ratio we are looking for? NO and H2O. What is the mole of NO in the equation 4? So it should be on the top. And H2O, which has been given over here, it is bottom 6, right? 4 over 6. Now see. You can solve now. Mole H2O cancel. On the top we got 15 times 4 divided by 6. What we get? 10 mole of NO. Interesting, right? Let me show you the other way, like I did. I said mole ratio, right? So how we do it? You start from the same place, 15 mole of H2O. We make two columns, one given, one we have to find. H2O. Second we have to find NO. Look at the equation. What is how many moles of 6? How many mole of NO? 4. What are the number of moles given in the problem? 15. NO, we don't know how many moles, so it is X. Cross multiply. 6X is equal to 15 times 4. Both sides divide by 6. Cancel. Now let me solve over here. X is equal to 15 times 4. Use your calculator. It should be 60 divided by 6, 10 mole. Same answer like we did in the previous method. Good? Okay, let me put the other method on the screen and then Any question may ask in the comment section. This is the volume of gas. On the top, mole is the center point. So whenever you are solving any problem, first step after balancing of equation. Actually, balancing of equation is the first step. Then second, find out number of moles. If you have to find moles into mass, multiply by molar mass. If you are about to moles into particles, then multiply Avogadro's constant. If you have to find volume of a gas, remember that 1 mole of any gas contains 22.4 liters at STP. STP means standard temperature pressure. You will know in details when you will get to chapter gases. Standard temperature pressure, 1 mole of any gas has 22.4 liter of volume. Let me show you some problems how we use this mole, mass and particles or atoms or molecule. Okay, ready? Let me show you now. You have been given 22.989 gram of sodium. How many mole? So we got 1 mole. Or if we start from, this is sodium. How many moles? 1. So what is the mass of sodium of 1 mole? So go to the periodic table. You see the mass of sodium, atomic mass, 22.989 gram. So that's our answer. 1 mole is equal to 22.989. Now they say how many particles or atoms or molecules in 1 mole of sodium. So when we have to convert mole into particles, we multiply by this number. This number 6.02 times 1023 is called Avogadro constant. So now 1 multiplied by 6.02 times 1023. Our answer is 6.02 times 10 raised to the power 23. Now, second question. Now they ask 2 mole of sodium. Go to the periodic table, find the molar mass of sodium, which is 22.989, multiply by 2. You got this number, that's the mass in gram. How many particles in it? Now multiply by this number. And when you multiply 2 by this number, it becomes what? 1.204 times 10 24 raised to the power 24. Now, third question, 0.5 mole of sodium. So we go to the periodic table, find the molar mass of sodium, which is 22.989, multiply by 0.5. You got 11.4945, multiply by this, 6.02 times 1023, Avogadro constant. Avogadro constant given by Emilio Avogadro, that's why we call it. So 0.5 times 6.02, we got this number. Now, question number 4, water H2O, we know 1 mole. Always start from mole, 1 mole. What is the mass of 1 mole of water? Go to the periodic table, find the molar mass of hydrogen, which is 1.007. There are 2 atoms of hydrogen. Therefore, what you did? Multiply by 2 plus molar mass of oxygen. Oxygen is 1, so 15.999. Add both of them. You got 18.03. This number multiplied by 1, we got this. How many particles or atoms? 1 multiplied by this number, we got this. So what do you notice? 1 mole of anything, regardless it's copper, it's an apple, 1 mole of carrot, 1 mole of vegetable, 1 mole of mangoes, 1 mole of pencils, 1 mole of pen, 1 mole of paper. How many particles? Always 6.02 times 1023. You do not need periodic table. What is the mass in gram? Then you need periodic table to find. Let me show you another example here. Number 9, copper. They say 0.5 mole of copper. First thing, what is the mass? They ask, what is the mass? Go through the periodic table, find the molar mass of copper. What is molar mass of copper? 63.546. Check your periodic table. Multiply by 0.5. So you got 31.773 grams. That's the mass of the copper. How many particles? Again, this 0.5 multiply by this number 6.02 times 1023. You get this number. Did you notice one thing? 0.5 mole of copper is also same like 0.5 mole of sodium, like 0.5 mole of water. You can take this picture, and I hope your teacher would provide you mole roadmap. So mole roadmap is really important, and always find it. Now, what I told you earlier, 1 mole of any gas, like I say, what is the volume of O2? Volume of 1 mole of O2. What is O2? Oxygen gas. 1 mole of O2. What is the volume? 1 times 22.4 liters. That's what mentioned in the previous slide. 1 mole of any gas, 22.4 liters. The answer would be 22.4 liters. When gas is at STP. Now change the question. Volume of 1 mole of H2. Again, the answer same, method is same. Nitrogen gas. Any gas is always 22.4 liters. So this is about stoichiometry. This is about mole, mass, atoms, particles, or molecules conversion. I hope you got everything. You understand it clearly, but something is not clear. Don't hesitate to ask us in comment section. If you like the video, please share with others. If you haven't subscribed our channel, please subscribe it now, and don't forget to click the bell icon so that you can receive the notification of new video. Thank you so much. Have a wonderful day.